Alright guys, welcome to the fourth video. The section 4 is going to be on trigonometric functions of any angle. So in section 2 we did specifically the angles on the unit circle. Section 3 we did angles in a triangle. Now we're going to do any angles, and specific angles that are in standard position. Now some angles that are in standard position, for angles that are in standard position, we're going to follow these definitions. Now, this is an angle in standard position, right? We got the initial side on the positive x-axis and the terminal side somewhere else. Sine is going to be defined to be the y-coordinate of whatever the y-coordinate is in the problem, divided by r, and r is the distance from the origin to the point that we care about. Similarly, cosine is the x over r, and everything else follows suit from the identities that we learned back in 4.3. So let's go on to the first example here, and we have this point 3,4. It's a point on the terminal side of the angle theta, and we want to find the sine, cosine, and tangent of theta. Okay, so if it's on the terminal side of theta, we're going to have our angle in standard position, which means we have the initial side on the positive x-axis, and the terminal side is somewhere. Well, that somewhere, though, is wherever this point negative 3,4 is. Negative 3,4 doesn't have to be perfect, just have to get it in the right spot. It would be 3 to the left. Sorry, my pen here. 3 to the left, and 4 up. 1, 2, 3, 4. So it's actually over here. That's the point negative 3,4. And that since it's on the terminal side of the angle, my angle looks like this. It goes through that point. Okay, so how do I find sine, cosine, and tangent of theta? Well, what we want to do is we can drop down a vertical to the x-axis, and we create this right triangle. Now, theta is actually this angle here, okay? But we don't really want to use theta because in terms of sine, cosine, and tangent, we can't really think of a triangle. And so we can use what we found on the first page, where sine, let's go back, is y over r. And the y-coordinate is 4. The question is, what would this r be, right? Because we're not given that. All we know is over here is negative 3, and up here is 4, because that's how we plotted that point, right? So we have to find this r value then. Well, notice this is a right triangle that's created, and we can use Pythagorean theorem to find that r value, which is negative 3 squared plus 4 squared equals r squared. I'm going to put r in my picture right here. Negative 3 squared is 9, 4 squared is 16, equals r squared, so 25 equals r squared. So therefore, plus or minus 5 equals r, and r will always be the positive value, so that's going to be a positive 5. So in this case, sine of theta is y over r, so that's going to be 4 over 5. Cosine of theta is x over r, so that's going to be negative 3 over 5. And tangent of theta is going to be y over x, and that's going to be 4 over negative 3. Okay? Now, if you're not sure which one's going to be negative, which one's going to be positive, and you just want to use the two coordinates, 3 and 4, you can do that. But just know, and you can determine the sign of the answer later, if your point is in the first quadrant, all of the trig functions, sine, cosine, and tangent, are going to be positive in that quadrant. In the second quadrant, the only function that's going to be positive there is going to be sine. And I'm creating an acronym here. So all students, A is for all, S students, we remember that with sine for S, take and calculus. So the acronym is all students take calculus. And the T stands for tangent being positive down here, only tangent. And C stands for cosine being positive down here. Only cosine is positive here. So sine is positive, tangent is positive, cosine is positive. The other trig functions are going to be negative in those quadrants. All of them are positive in the first quadrant. So instead of making this picture with a -3, you can just look at the point and know sine is y. You can find r by using Pythagorean theorem, and you can determine the sign of your answer just by looking at what quadrant you're in. Well, let's try example 2. Given sine is -2/3 and tangent is greater than 0, that means tangent is positive. We want to find cosine and cotangent. Well, in order to do that, let's figure out what quadrant we're in. If sine is negative, that gives me two options. I'm either in the third quadrant or the fourth quadrant, because sine is positive here and here, so if sine's negative, it's got to be either here and here. But that's not good enough. I need to know exactly which quadrant I'm in. But because tangent is greater than 0, meaning tangent's positive here and here. So which one of these two spots satisfies them both? This spot here. Tangent's positive here and sine is negative here. Therefore, we must be in this third quadrant. So we can draw a picture. I'm going to draw my angle in standard position. So my initial side is here. And my terminal side is going to be somewhere over here. Where exactly? Well, if we know sine is -2/3, and sine, remember from the front, is y over r. If I make this right triangle by dropping down a vertical, every time we're going to drop a vertical, the y-coordinate I know is going to be 2. Now, is the y-coordinate positive or negative down here? Well, since sine is negative, the y-coordinate has to be negative. So I'm going to go down 2 here. And my point is something comma -2. I don't know what that something is, but we'll get there. R is 3. Okay, so that's the hypotenuse. How can we find this coordinate? Well, once again, Pythagorean theorem. Something, the x-coordinate squared, plus the y-coordinate squared is equal to the hypotenuse squared. So x squared plus 4 is equal to 9. So x squared is equal to 5. So x is equal to plus or minus the square root of 5. Depending on which quadrant we're in, we know if we're going to use the positive one or the negative one. Because we're in the third quadrant, we have to go to the left, which is the negative direction. This side will be -√5. Now we can find cosine, because cosine is x over r. And we just found x to be -√5, and r is 3. So therefore, cosine is -√5 over 3. Cotangent, go back to that front page if you don't remember, is going to be x over y. In this case, x was -√5, y was -2. Negative divided by negative ends up being positive. So I'm going to write this as √5 over 2 for cotangent. All right, moving right along. We've got example 3. Evaluate the sine and cosine functions for these angles: 0, pi over 2, pi, and 3 pi over 2. All right, so I'm going to start with the 0 angle. 0 angle has an initial side right here and a terminal side also right there. Notice it doesn't give us a point, so we can choose whatever point we want on this terminal side. So I'm going to choose this point, 1, 0. That's definitely on this terminal side, and it's an easy point to work with. So therefore my x is 1 and my y is 0, and my radius, well, guess what? It's on top of it, right? So my radius is also going to be 1. Okay, so what is sine going to be? Well, if my radius is 1 and my y is 1, sine is y over r. So we 1 over 1. Oh, I'm sorry. Y is 0 here. My r is 1, so it's going to be 0 over 1, which is 0. Cosine of theta in this case is x over r. X here is 1. 1 over 1 is going to be 1. And that's it for the first one. I'm going to write 0 here, not theta, because we know what angle we're working with. Now let's do pi over 2. Okay, pi over 2 is this angle up here, somewhere on this ray. So again, I'm going to choose an easy point. somewhere on this point, somewhere on this ray. That point's going to be 0, 1. Okay, sine is y over r. Once again, my radius is right here, because if I drop a vertical, it's right on top of itself. But now my y value is 1. 1 over 1 is 1. Cosine of pi over 2, x over r. X is 0, r is 1. 0 over 1 is 0. Now let's do pi. Pi is going to be over here, right? I'm going to choose any point on that ray, an easy one. In particular, -1, comma 0. And sine is y over r. The y in this case is 0. The radius again is still 1, because it goes from here to the center, which is 0. And cosine of pi is x over r, so -1 over 1, which is -1. And yeah, okay. And then for 3 pi over 2, we're going to be down here. And again, I'm going to choose an easy point. That easy point is going to be 0, -1. So therefore, sine is going to be y over r, -1 over 1, which is 1. Similarly, x over r, 0 over 1, 0. All right. Moving right along. So we're going to talk about reference angles now. Now, when angles are greater than 90 degrees or less than 0 degrees, they are no longer in the first quadrant. And in that case, we can still think about the angles being acute, that is between 0 and 90 degrees, by looking at the reference angles. The reference angle is defined to be the acute angle formed by the terminal side of the angle theta and the horizontal axis. So in this case, here's my angle. It's in standard position. Here's theta right here. Theta prime is this reference angle, basically the amount of rotation from the terminal side to the x-axis. And it's always acute, and it's always positive. So to find this angle, if you're in quadrant 2, if you're working in radians, you take pi because that's halfway around, take away this angle theta, and you'll get this angle theta prime. That's how you read this, theta prime. Or if you're working in degrees, it's 180, because 180 is halfway around. Take away the angle we're given to find this reference angle. Similarly, if you're in quadrant 3, to find the reference angle, you're going to take the angle given, take away the halfway point to find what remains. And that calculation is here. And the last one you can find by doing this. Instead of going the halfway point, if in quadrant 4, you have to go to the full way around, which in radians is 2 pi. And in degrees is 360. So let's try this example. Find the reference angle theta prime if theta equals 300 degrees. All right. So I'm going to start by doing a sketch of 300 degrees. Not going to be perfect, but my initial side is here. Okay. 300 degrees is going to be right about here. All right. That's a theta equaling 300 degrees. So what would theta prime be? Theta prime is going to be right here. Now, since we're in the 4th quadrant and we're in degrees, I'm going to use theta prime equals 360 degrees minus theta. So theta prime is going to be 360 degrees minus 300 degrees, or 60 degrees. So that's going to be 60 degrees. Now, the next one is 2.3. Notice there's no degree symbol here, so we have to assume it's in radians. And about where that is, it doesn't matter if you know where it is or not. You just have to know pretty much which quadrant it's in. Halfway around is pi radians, right? Which is about 3.14. A quarter of the way around is pi over 2, which is about, well, 3.14 divided by 2 is 1.57. So it's going to be past that. So we know we're in the second quadrant somewhere. Where exactly? I don't know, but about there. And if we're in the second quadrant, we're going to be using this conversion for radians. theta prime is going to be pi minus whatever theta is. So in this case, here's theta prime, and theta prime will be equal to pi minus 2.3. So in this case, theta prime is approximately, well, let's go ahead and do that. Pi minus 2.3, and we find it's about 0.85. All right, so theta prime is about 0.85 radians. All right, let's do negative 135 degrees. So remember, negative, we're going to be opening up in the clockwise direction. And this is 90, this is 180, so we're somewhere in between, about here. So that's negative 135 degrees, that's theta. Theta prime is going to be this angle here. It's always positive, so notice I'm drawing it in the positive direction. And if we're in the third quadrant, we're using this conversion here. We're in degrees, so we're going to take this angle theta, subtract 180. Now, the issue here, let's try to do it with exactly negative 135 and see what happens. According to our calculations, theta prime should be negative 135 degrees minus 180 degrees. But as you can tell, this is negative 315 degrees. And that's definitely not a positive acute angle. So first, what I suggest doing is figuring out, the other way you can think of this is figuring out how far away you are from the halfway point. Well, if I went 135 degrees, how much further do I have to go to get 180 degrees? That's going to be 45 degrees. I need to go 45 degrees more. Therefore, theta prime here is actually 45 degrees. But if you think about it, negative 315 degrees would be, if you add 360 to that theta positive one, you'll find it's also 45 degrees. So if I add 360, I would get that 45 degrees that theta prime actually is. Okay, and then this is just some notes for you. To find the value of a trigonometric function of any angle theta, first figure out the function value for the associated reference angle, theta prime, and then depending on which quadrant theta lies in, affix the appropriate sign to the function value. Okay, so let's use that. And here's some common angles that you should be familiar with, and if you're not familiar with, you definitely want to be familiar with these ones. It was in the last packet as well, but this 90, 180, and 270 wasn't in the last packet. But we just did that earlier in this packet anyway. Point is, these are very common angles to use, 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, or similarly in radians. They're very common. You'll see them all the time. So you definitely want to get comfortable. You definitely want to memorize these numbers in the table. And there's a quick pattern here that can help you memorize. So I really suggest you read through that and try to understand that pattern. Okay, so let's evaluate each trigonometric function. Now, 4 pi over 3, I'm going to do a quick sketch of where 4 pi over 3 is. 4 pi over 3, well, is that halfway is pi, right? And pi is 3 pi over 3, so I'm a little bit past halfway. So my angle is going to be right here. This is theta, right? That means theta prime is here. To find that, just like on the previous page, it tells us to do theta prime is equal to theta, which is 4 pi over 3, take away pi, which is, so we can represent that as 4 pi over 3 minus 3 pi over 3, which is pi over 3. So theta prime is pi over 3. So if we look at pi over 3 up here, find cosine, it's 1/2, right? So cosine of pi over 3 is 1/2. Now the problem is we're in the third quadrant. Oops, sorry, you can't see that. So cosine of pi over 3 is 1/2. The problem with this answer is that we're in the third quadrant, right? And if you remember, all students take calculus. The only function that's positive down here is tangent. So therefore, cosine down here has to be negative. So our final answer is going to be cosine of our original angle, 4 pi over 3, is actually negative 1/2. All right, let's try it again with this tangent of negative 210 degrees. I'm going to draw a quick sketch of where we're at. negative is going to go in the clockwise direction. 180 is halfway around, so we're a little bit past that here. So that's theta. Theta prime is going to be this angle here. Okay, that's theta prime. And whenever I'm working with negative angles, I like to take a conceptual approach instead of a formulaic approach. If I went 210 degrees, how far past is at the halfway point? How far past 180 degrees did we go? So how far away is 210 from 180? It's 30 degrees away. So therefore, theta prime is 30 degrees. And we're trying to find then, if we can do tangent of 30 degrees, we can do tangent of negative 210 degrees. Tangent of 30 degrees, let's look back up to the table. 30 degrees is here. Tangent of 30 degrees is root 3 over 3. Okay, so this is root 3 over 3. And now, what quadrant are we in? All students take calculus. We're in the second quadrant. The only thing positive here should be sine, and since we're evaluating tangent, our final answer is going to be tangent of negative 210 degrees is actually negative root 3 over 3. Okay? Cosecant of 11 pi over 4. We got to think about where we're at. Halfway around would be 4 pi over 4 because it's pi, and 4 pi over 4 is pi. All the way around is going to be 8 pi over 4 because all the way around is 2 pi over 4, 2 pi. And so converting that into fourths, it would have to be 8 pi over 4. But we're at 11 pi over 4. So I know I'm going to be more than one rotation. And how much more? Well, if 8 pi over 4 is one rotation, we need 3 pi over 4 more. So that's not quite halfway. It's going to be somewhere about here. Okay, so there's our angle. That's theta. Theta prime is going to be here. All right. And, okay, so how far away from here are we? Well, all the way around was 8 pi over 4. So from here, let me use this color. From here to here is 3 pi over 4 because 8 pi over 4 was one revolution and we went 3 pi over 4 more. And halfway around is 4 pi over 4, right? Or pi. So how much more pi's over 4 do we need? We need a single pi over 4. So theta prime here is going to be pi over 4. Okay, and we want to do cosecant. Now remember, cosecant of pi over 4 is the same thing as 1 over sine of pi over 4, or the reciprocal of sine of pi over 4. Sine of pi over 4 is root 2 over 2. Okay, so this is 1 over root 2 over 2. Got to simplify this. Instead of dividing by root 2 over 2, we can multiply by 2 over root 2. So we get 2 over root 2, but we have to rationalize that. So we're going to multiply by root 2 over root 2 to get 2 root 2 over 2, which simplifies to root 2. So that's for pi over 4. But we are in the second quadrant. All students take calculus. Well, looks like sine is in fact positive here, and since cosecant is the reciprocal of sine, cosecant is also going to be positive there. So our final answer is going to be cosecant of 11 pi over 4 equals root 2. Okay. Almost done. One more example. Let theta be an angle in quadrant 2 such that sine of theta equals 1/3. Find cosine of theta by using trigonometric identities. Okay, so we have to use identities here. Now, if you recall, quadrant 2, all students take calculus. This is 1, 2, 3, and 4. So the only function positive in quadrant 2 is sine. So I know cosine, my answer, has to be negative because I'm in the second quadrant. And trigonometric identities, I'm going to use what involves sine and cosine? The Pythagorean identity. Pythagorean identity, if you recall, is sine squared of theta plus cosine squared of theta equals 1. That's the identity that we need to use because that involves sine and cosine. Sine is given to be 1/3, so 1/3 squared plus cosine squared of theta equals 1. So 1/9 plus cosine squared of theta equals 1. Subtract 1/9 from both sides, so cosine squared of theta equals 8/9. And to solve for cosine now, we have to square root both sides. So that's going to be the square root of 8 over 9, which is equivalent to the square root of 8 over the square root of 9, plus or minus, right? Plus or minus, plus or minus. So that's going to be plus or minus root 8 over 3. And root 8 can actually be simplified as well because it's divisible by 4. So you want to write this as plus or minus root 4 times root 2 over 3, which is plus or minus 2 root 2 over 3. Now, we're not going to actually have in our answer both the positive and the negative because cosine is, we know for a fact, is negative in the second quadrant. So our final answer is going to be cosine of theta equals negative 2 root 2 over 3. And that's it. So we're going to continue working on this in class next time, and we'll see you then.